Hey guys, this is question MM142 of the Maths Methods Fortify study guide. Now this is an application style question. So we've got this river, it's used as a way for cargo boats to reach a village 20 kilometers from the mouth of the river. The depth of the water in the river in meters throughout the day is multiplied by the function d of t equals 5, take 2.5 sine of pi t on 6, where t is the number of hours after 6 a.m. So that's really important. T after 6 a.m. Fantastic. So our question A asks us, what is the maximum depth of the river and at what time does this depth first occur? Great, so there's two questions here, the maximum depth and the time at which it occurs. So let's work out what the maximum depth is going to be. So our maximum is always our midpoint plus our amplitude. So our midpoint is 5 and our amplitude is 2.5, which means that our max is going to be 5 plus 2.5, which is 7.5 meters. That's our maximum. So that's our first mark straight away. Pretty easy. At what time does this depth first occur? So in order to find out what time it occurs, we need to sub this 7.5 back into our equation. Okay, so we get 7.5 equals, so we're subbing this back into here. 7.5 equals 5, take 2.5 sine, 2.5 sine of pi t over 6. Rearranging this, we get -1 equals sine of pi t on 6, so inverse sine of -1 is equal to pi t on 6. Keeping in mind where sine is -1 is at the bottom of the unit circle, where x equals 3 pi on 2, so pi t on 6 is equal to 3 pi on 2. Rearranging this, we actually get t is equal to 9. But this is not the end of our question, remember, because the question asks us at what time does this depth first occur? Not what value of t, it says what value of time, what time does it occur? We know that t is our number of hours after 6 a.m., which means that when t equals 9, our time is 9 hours after 6 a.m., which is equal to 3 p.m. So time equals 3 p.m. I would even at the end write max depth of 7.5 meters occurs at 3 p.m. just to ensure getting all the marks. If you write max equals 7.5 meters, time equals 3 p.m, should be fine, but I like to just summarize it at the end. So that's all good. That's part A, guys. Please let me know if you have any questions, as always. But let's move on to part B. I keep doing that. I keep I keep rubbing out this bit. So 5 take 2.5 sine of pi t on 6. Sweet. And we're going on to part B now. So part B asks us to sketch something. Sketch the graph of d of t for t from 0 to 24 on the axes below. Label axis coordinates and endpoints. Awesome. So we've got this axis here, where this is t and this is d. So there's a couple of points here. We've got our sine graph. We know that it's a sine graph. Obviously it tells us that it is. So it starts in the middle of the midpoint, and our midpoint is this bit here, number 5. So I like to do a bit of a dotted line at my midpoint. It just helps me keep track of everything. So this is going to be our 5. Our maximum is going to be equal to 5, our midpoint, plus our amplitude, which is 2.5, and we did already work this out. 7.5, and our minimum is 2.5. Now it's not exactly to scale, but you get the idea. So from here, we know that our period, well, we haven't actually worked it out yet, so we need to work out our period. So we know that our domain is 0 to 24, and our period is equal to 2 pi over our coefficient of x, or coefficient of t in this case, which is pi on 6, which means our period is equal to 12. So if, let me just write these in, if our domain is 0 to 24 and our period is 12, that means we're going to have 2 cycles within this domain, right? So our first cycle is going to start here and end at 12, right? Because our period is 12. And our second period is going to end at 24. So, because it's a negative sine graph, it's going to go down first, come up like this, down through here, up like this, down through here. So we know that it's going to pass through 6 and 18. It's going to pass through here and here, as well as here and here. And again, it's not completely to scale, but you get the idea. Fantastic. So we now need to label our endpoints as well. We know that this is 24 and our midpoint is at 5, so it's 24, 5. And our endpoint here is obviously 0, 5. Guys, that's it. You don't have to do anything else. You've labeled the coordinates that it kind of passes through. You can even label 3, 9, 15, and 21 here as well, just to make it super clear. You've got your minimum and maximum, and you've got your endpoints, and that's it. That's your graph. So let's move on to part C, and we'll talk about whatever we need to talk about. So, alrighty, we've got, due to the size of the cargo boats, they require a depth of at least 6.25 meters. So depth is at least 6.25 meters to travel safely on the river. Between which times are these boats safe to travel down the river? Awesome. So I'm just going to redraw that graph very, roughly. So this is 7.5, 2.55. So they require a depth of at least 6.25 meters. So 6.25 meters high is somewhere here, right? So we need these points here, right? Because these are the only times that the cargo boats can travel down the river. So between which times are they able to safely travel down? So we need to figure out this time, this time, this time, and this time. Awesome. Because these are the times that it's above 6.25 meters, right? So we need to figure out the first time that it's above 6.25. So if our depth is 6.25, that means that 6.25 is equal to 5 take 2.5 sine of pi t on 6. Awesome. So from here, what we actually get is -1/2 equals sine of pi t on 6. Inverse sine of -1/2 equals pi t on 6. 7 pi on 6 is equal to this. So 7 pi on 6 equals pi t over 6, which means that t is equal to 7. You can kind of see that there. T and the 7 are the only things that are different. If you're unfamiliar with how inverse sine of -1/2 is equal to 7 pi on 6, please review your unit circle stuff and come back. So, since the maximum depth occurs at 9 meters, which is what we could tell from the graph, remember how this bit here was 6, this was 12, which means in between is 9. That means that there's 2 hours here and 2 hours on this side, right? Which means that between t equals 7 and t equals 11, our cargo boats could travel, right? But remember, we're talking about our time, okay? So 7 hours after 6 a.m., because remember t is our time after 6 a.m., 7 hours after 6 a.m. is 1 p.m. So can travel between 1 p.m., because t equals 7 is 1 p.m., and 5 p.m., because when t equals 11, the time is 5 p.m. But we also have this bit over here. And remember that our period is 12 hours, so our cargo boats can actually travel 12 hours after this and 12 hours after this, which means it is also above 6.25 meters from 1 a.m. and 5 a.m. right? So they can travel above 6.25 meters between 1 p.m. and 5 p.m. and between 1 a.m. and 5 a.m. So guys, this is a 3-mark question. Your first mark comes when you recognize that t is equal to 7. And then your second mark comes when you recognize it can go between 1 p.m. and 5 p.m. And your third mark is given when you answer the whole question, making sure to include 1 a.m. and 5 a.m. So that's part C, guys. Please let me know if you have any questions about it. Let's move on to part D now. So, let's change this as well. If the boats need 40 minutes to unload their cargo at the village docks, what is the minimum average speed they must travel at in order to enter and exit the river safely in one trip? Cool. So during one trip, according to our graph, from here to here is 7 and 11, which means they actually have 4 hours to do the trip safely. Once they're either side of this 4 hours, it's not safe anymore because the river's too shallow. So they need 40 minutes to unload their cargo at the docks, and they need to travel 20 kilometers, right, to get to the mouth of the river, because the village is 20 k's away as per the question. So let's say the mouth of the river is here. They come down here. This is 20 kilometers. So they come along the river to the village. This is the mouth. To the village, wait here for 40 minutes, and then they go back outside, which is another 20 kilometers, right? So during this whole one trip, the 4 hours, they have to travel 20 kilometers this way, wait 40 minutes, and then travel 20 kilometers this way, which means that they have 240 minutes or 4 hours for the whole trip. They wait at the village for 40 minutes for their cargo to be unloaded, which means they have 200 minutes to travel, right? So they have 200 minutes to travel 40 kilometers. And remember that our speed is probably more likely to be in kilometers per hour, right? So we need to convert this 200 minutes into hours. So 200 divided by 60, which means that our hours is equal to 10 over 3 hours, right? So our speed is actually equal to distance over time. And we know that the boats have to travel 20 this way and 20 this way, so 40 kilometers all up, over the time of 10 over 3 hours, which means that our distance is 40 over 10 over 3. Which is equal to 12 kilometers per hour. So the boats have to travel at an average speed of 12 kilometers per hour in order to get to the village, wait 40 minutes, and then get out of the village before the river becomes too shallow. Your first mark is around here. So when you recognize that they have 40 Ks and 10 over 3 hours to travel that, and then your second mark is your actual average speed. So the boats could go faster than this and they could go slower than this, but this is the minimum average speed that they need to maintain in order to get in and out of the river safely. Guys, that's part D, which wraps up question MM142. If you have any questions about it, please hit me up in the comments below. But as always, guys, have a great day.